Hello everyone, welcome back to FX021. So in this tutorial, I'm gonna walk you through this smoke effect, which is pretty cool. So let's get started. So I'm gonna walk you through the project, and I'm gonna explain how I made this effect. Okay, so first thing first, you need to set your project. You can go to the file, new project, set your project path, name, and accept. Okay, and so first thing first, I create a source for my particles, because for smoke simulations, to get a good result, you need to basically, you always want a particle simulation as your emitter, so it's getting a more natural look. Okay, that's what I do. So I emit particles first, then I generate the smoke from the particles. Okay, so let's dive inside the source node. So it's pretty simple. Just a sphere here. You can copy the parameter if you want to follow. So I have a rotate value here set to $f times 20, which $f is your frame number. So $f at the first frame is 1. So 1 times 20 is 20. And second frame 2 times 20 is 40, and so on. So it will rotate on the z-axis. Okay, if we play it, you can see it's rotating. If we use a box to make it more obvious, so I'm gonna copy the expression here and paste on the rotate on the z-axis on the box, so it's more obvious. So yeah, you can see it's rotating like this. So that's our sphere, and it's rotating, and I add a mountain node just to have some noise on top of the sphere. And you can just copy the value here if you want to follow. I basically change the amplitude here and turn on the animate noise. Yeah, and and create an out for my source. And now let's dive inside our procedural animation. Let me turn off the render smoke and mix here. So inside procedural animation here, we can see, yeah, I create a template body here just to get a real world reference. So this guy is around 1.8 meters tall, I think, so that my smoke is gonna be kind of like this big. So yeah, just to get a reference for my scene size, we can create a test geometry here. Okay, and first thing first, I create a circle, and as you can see, it's reversed. So I just and the circle, I increase the division size, and that's z-axis plane, and I change it to polygon. Okay, and then it's reversed. So I just reverse the normal, and then I use a copy and transform node. So copy it 3 times on the y-axis, so something like this. Okay, and then I delete the geometry. So I delete the circle, but only keep this point here. So using an add node here, under the point tab, there is a delete geometry but keep points option here. Just check that, and then this will leave left only points there. Okay. What I want to do here is I want some of the point. I will copy my sphere on some of the point and then emit particles so that it will like surround this guy here. The particle will be like surrounding this guy like a circle. So, but I don't want all these point to like I will copy my sphere to the point, but I don't want all sphere like sphere copy to every point. So I need to like randomly delete some point. So I'm using some code here in the attribute wrangle here. I'm gonna do it now, like I will do it from scratch so that you can understand. Okay, use the attribute wrangle node here. So delete randomly. So if we use let's use f at test. So we want to create a random value here. So random and add pt now, which is our point number. So for every point, your point number will be different. So for this point here, it's 4. And for this point, it's 3. So when the code run over the point number will be different. Okay. So the random value will be different. If you feed in the same value, let's say random 1 here, it's not gonna be a random value because you're feeding the same input, so the output will be the same. So if you go to the geometry here, you see the test here, you see it's all 0.00292516. It's all the same. It's not random value, but when you change to add point num, and now you can see the test here, 0.0. When you fit the point number is 0, the random value get to 0.4. So when the point number is 1, it's 0.002. So every point got a different value. So the random function give you so random function returns a value between 0 to 1. Okay. So if it returns a value between 0 to 1, so I just gonna create a channel called threshold. So I'm gonna, if the random value is less than my threshold I create, then I'm gonna remove some point. Okay. So that's what I'm gonna do. F my random value at point num. So it's gonna be like, it's maybe a new value. So less than, let's say 0.5. Let's now set the color to red. So 1 0 0. It's easier. Okay. So now let's go to the dark mode here. Now you can see some of the point are red, some of the point are white. So the point are red is because the random value maybe on this point 136 here, the point the random value he gave is less than 0.5. So it set the color to red. But it's not convenient because if you want to change it, you need to go into the code and like type change the value here. So basically it's a percentage because it's lower than 80%. So 80% of the point will be selected. So we want to turn it to a slider, so we can use and it's a float number, so we can use a channel float and name and give it a name, any name. So I'm gonna call it threshold and just click the button here, and now you can see when it's 0, no point are selected, and when you increase the slider like threshold, like lots of point get selected. And yeah, that's how I randomly select a point and delete point here. And anytime you don't know, for example, a random function, you don't know what to write inside the function, you just hover your mouse on the random here and press F1 on your keyboard. It will go to the API, which tells you, it will pop up a Houdini like kind of website, tell you, like, you see the random function will give you a float number, returns a float number, and you're feeding a float. So yeah, so it creates a random number between 0 and 1 from a seed. So the seed here is our point num. Okay. Yeah, and now we can remove some point. We don't want to set it to red. We want to remove point. So for remove point, you just type remove. Wait, I'm gonna comment my color here. I don't want to delete it. So for remove point, you just type remove point here, and you don't know what's inside it, so you can just press F1 to check. So it will tells you the remove point function removes a point from geometry, and the first input is the geo handle. So the geo handle is gonna be 0. So the 0 means the first input first input here, and yeah, because we're gonna remove the point from this geo, so it's the first input here, and the point num. So the point num is gonna be our current point. So now you can see the point are removed when you change slider. Okay, so I'm gonna delete this one. So that's how I delete points. So I set to 0.952, so you can copy the value, and then I just create a sphere here, really small, and change it to polygon, and radius 0.5, scale 0.11, and copy it to point. Now I got these spheres surround this guy here. Okay, and then I let's go to the first frame, and there is a pop network here. So I do the particle simulation. Normally when you do particle simulation, you always want to create your velocity attribute. And because you want some random velocity here, but for this one, because it's simulating like a kind of like a circle pattern here, I'm not creating any velocity attribute in the stop level, so I'm completely down in the pop network. Okay, so I'm using this sphere as the emitter, and now let's put our view flag on the pop network. You can just create a pop net by typing the pop network here. Okay, and yeah, let's play it. You can see we have these particles around this guy, and yeah, let's dive inside. Everything is pretty basic. When you create your pop network here, you got this node here just beside these two. So yeah, so for the source first input here, use the first contact geometry, which is this one here, and in the burst tab, because I don't want too many like smoke. I don't want too many these green things like inside the smoke. So I only active this particle at the first frame. So basically, this point here, these particles are only active in the first frame, and they are stay there because they don't have velocity feeding, so they stay in place. You can see they are moving a little bit because I have a pop wing here, so but I set amplitude to 0.15, so they are moving a little bit, but not too much. But they don't have velocity in the sub level, so they don't move, and they only spawn at the first frame, and then there's no more new particles spawn. So that's what I do here. So $f equals 1, and they will spawn 150 particle at first frame, and yeah, the life expectancy 100. I don't want them to die, so yeah. And yeah, nothing here. They inherit velocity, but there's no velocity, so they're not moving. And for the pop axis forces, it's the sphere here surround this, and the sphere here will create a force to like make this particle turn around. Okay, so you can copy the parameter here. So I think you don't have the skill and the O skill here. I'm gonna talk this later. So you can change the radius to 2 and the height to 2. That's because when you go back to sub level, we made our circle radius to 2. So the sphere here, the radius is 2, so this sphere are gonna be exactly on the surface of this huge sphere here. So they will have the force to turn around inside around this guy. Okay, and the speed here, I use the Vex expression. I'm gonna talk this later. So the fall off, you can copy the value. I think it's default, and everything here is default. You can copy the orbit speed and suction speed here. So if you set your orbit speed to 8, suction speed to 5, and you don't have Vex expression turned on, and you play the animation, play the simulation here, you can see every particle moves at the same velocity, and it's not very interesting. So when you turn on the Vex expression here, and you see these particle kind of like have different velocity, which create a more interesting result. So the code here is actually very similar to the code here. So I'm using a random function just to create a random number, so that and multiply a scale here, so that every particle will get a different value, and assign that and multiply that to the suction speed. So multiply equals itself, and it will get a random value on each point. And the suction speed, the name, you need to be exactly the same as this, because when you hover your mouse on the suction speed here, you can see the parameter here is called suction speed. If you have spelled it wrong, then it's not gonna work. Okay, and as well as the orbit speed, the parameter is should be exactly the same. So this, and the code here is these two lines are doing the same thing, I just have different value for each thing. So that's how you get different velocity when you're using the pop axis forces. And then I just use a pop wind to just add some noise when they move. So you can copy the value here, just a little bit amplitude and the swirly size here. So just to make it more randomly. So, and everything else just stay the same. Okay, you can copy the value here, shape, speed, fall off, and pop wing. Now that we have our particle simulations, while I play it, you can see these some particles are not moving because they don't have any suction speed or any orbit speed on these particles. only the one that get this speed will have velocity on them. So we get this one only have the swirly pop wing affecting this point, which we don't want. We don't want this particle floating there and do nothing. Okay, we only want these high velocity particles. So we want to find a way to delete these particles. Okay, so the way we're deleting these particles are like to find out the velocity. Based on the velocity, then we delete them. So I have another attribute wrangle here. So I'm gonna walk you through the code. So as you know that velocity is a vector, so it's hard to for us to compare the vector for each particle. So we want to turn that into a float. So if you select your attribute wrangle here and go to geometry spreadsheet and find your velocity here. Let me find. You can see it's a vector v at z, v at x, v y, v dot z, and you can see some are 0. Some are 0, and some are like have a 10 speed of 10, and some are like not moving. So we want to convert that vector to float. So I'm using a length. It's gonna calculate the length of the vector. So let's see. So f at test equals length at velocity. And select the wrangle node here, go to the add a geometry spreadsheet and find our test. Now you can see it's converting to a float, and it also has these different values. Now we can easily compare them. So it's the same principle as this one. So if the velocity is below our threshold, then we're gonna delete them. Okay, so you can see if the velocity is below the some value here, we set it to red. Okay, so I'm gonna do that. If length of our velocity is less than some value, let's say threshold, we're gonna set it to red. Okay, let's click the button here, turn off point display. So now you can see when you move your slider, you can see these points floating there are selected. Okay, now you can see the white point are fast moving point, and the red here are not moving too much. Okay, and you know how to remove point already, so you can just copy the function here and paste here. Now these points are removed. Okay, so you can copy the value here, 0.2, and yeah. And one thing I noticed is that the circle is too small, but we can't do post-process after the simulation. So I just create a transform node, scale on the uniform scale 3, so it's small big. Okay, and I have attribute randomized to the p scale. You don't see it, but it create an attribute here. Let's find it. P scale. You can see they have different p scale value here. So when you use copy to point here, the p scale value will affect the scale of the object. So the object here I merge from the source here we create here. It's the one have the mountain node here. So you just copy the out node here and use the object merge to bring it here. And yeah, and yeah, so after I randomize my p scale value here, I still think it's too small, so I transform again so it's even bigger. So I transform at 3 uniform scale 3 again, so it's larger. So I have 2 transform node. So yeah, and I copy 2 points, so now you can see the animation here. And if we disable the p scale, you can see every sphere here are the same size, which is not very good. So the attribute randomize here can have like a more interesting result. So when we have these spheres, we're gonna do another simulation using these spheres, and these spheres will be our emitters. Okay, so I create null here, name it out, and bring that to the this part. So using an object merge to bring that in this folder here. And you know, let's go inside procedural animation here. So after we do before we do the pop simulation here, you can see we only have position attribute, and after the particle simulation here, when you can see we have age, air resistance, color, dead, false, lots of attribute. And when we copy to point, all these attributes are still on our spheres. And because we gonna do another pop network, and these will also generate this information again, so we don't want to mess up our particle simulation. So I use an attribute delete to delete all attribute except the velocity. Okay, you see here we got so many attributes here, and when we use the attribute delete here, we only left with the velocity here. So attribute delete, this means delete everything. Okay, so we only have position attribute, but we do want the velocity from the particle simulation. Okay, because it's in a circle way, so we do want the velocity. So I just keep the velocity here. So now you can see we have the velocity. Okay, that's what I do here. And then I feed that into a particle simulation here. Okay, it's quite heavy. I can't play it in real time, but yeah, it's the cache here. You can see that's our particle simulation. This part I will be cover in the next video. Okay, so that's it for today. If you like the video, please hit subscribe to my channel, and yeah, see you in next chapter.